Hi, this is Chris, ZL1CVD. I've been playing around today with the Grintek TR-178, and I've got two of these, and this one has the manual tuner, so does the other one, and I found a fault in this one which I thought I would share with you. So here we have the transceiver unit and the tuner unit. Attached to the tuner unit you put the whip antenna, standard AT271 type whip antenna, or connected to here, the BNC connector, you can put a dipole. And tuning is accomplished, as I said, it's a manual tuner, and tuning is accomplished by turning this knob here up and down. When you go into a certain menu option in the transceiver, tuning menu option, it will produce a carrier, and as you turn the knob on the side here underneath, the LED indicators in behind here will tell you whether to go up or to tune down, so you know which way to tune. It's quite an interesting way of doing it, and it's very good for if you think about soldiers or something like that who won't be radio technical. So it's a very easy transceiver to operate and very solid. Surprisingly, the tuner unit is completely encased in a hard plastic. But anyway, I wanted to show you about the fault. This is actually an M10 stud or M10 socket for the antenna, which is a bit different to the 3824 that the standard AT271 uses. But you can buy adapters. I've seen adapters on AliExpress for converting the M10 to 3824 and vice versa. And I've seen on the European eBay sites like ebay.it or ebay.de, I have seen M10 threaded AT271 type antennas. Those are the standard military whip type antennas for backpacks, for HF backpacks. But as to the fault, this, on the inside of this case, has a nut that sits underneath here, which obviously tightens this and holds this in place. At the end of this whole assembly is a pin that comes down and goes into a circuit board. So if we have a look at the other tuner that I've got in pieces here, and to get them into pieces, just if you've got one of these, it's a matter of undoing 4 hex screws here. Take the knob off. It's got 2 hex screws, hex studs. Unscrew those, pull the knob off, and then the bottom will just separate from the top. And then you see a very finely made antenna tuner. It has 2 permeability tuned inductors, and by permeability and tuned, we're talking about the fact that the inductors are around on a non-ferrous former, and to change the inductance, a ferrous material, a ferrite rod, in fact, in this case, which is attached to this brass shaft, is inserted in and out of the inductor. Now this is quite a unique, as you see as I'm turning this, you'll see we have, if you like, fine tuning being done by this inductor, which you can tell because it's got sparsely turned coil on there. So the inductors is obviously not as great as this side, and in fact on this side the wire is the low capacitance litmus type wire, which is made by multiple threads of copper wire. And if you've done some electrical theory, you should know that they do that to reduce the skin effect on the copper, because as we go up in frequency, copper tends to the conductance tends to occur on the skin of the copper as opposed to through the center of the core. And to alleviate that, what we do is we use multiple cores of wire, and it's called litmus wire, I think. Anyway, that's all from memory. So if we have a look at this, let's just get back to I'm waffling. let's just get back to this. We can see that as we turn, notice how there's different gearing ratios for the two inductors. It's actually very smartly designed. So I live in Timaru, which is in the South Island town of New Zealand, on the about halfway down, just a bit lower than Christchurch on the east coast, and we're only a small town of about 30,000 people. And I've been all around town this morning. I couldn't find any petroleum jelly in my stock, and the brand name over here is Vaseline, and I've used it all for other jobs. So I couldn't find any. The country's actually sold out of. Turns out that we've sold out of this petroleum jelly. So I've just been up and I've bought a tub of multi-purpose engineering grease, and I've just put a small slither across these this brass work here, just so that it frees it up a bit. With anything that uses this sort of grease, over time the grease dries out, and I'm going to put a little bit here over these O-rings where it goes through the case here. It comes out through this hole here, and that will just help. And I will also put another bit, a little tiny wee bit around, all around here and around here, and on both sides. This is actually a washer to maintain water integrity. I'll put a little drop of it on either side. I might not put grease on this one. I'm a bit reluctant to use grease where it hasn't been used before. They've obviously used it here and here, so I'll continue to use it there. But up here I actually have a silicone spray, so I'll put some of that onto a cotton wool bud and I'll run that around. And it's I just find that over time grease and plastic is not necessarily a good idea. Sometimes the grease will eat into the plasticizer. But anyway, I just thought it was interesting to show you the way that this mechanism works for this tuner. As for the electronics in here, it's pretty basic. They're using they have a, well, I don't have a circuit of this, but just having a quick look at it, they're measuring forward and reflected power off it. And that's how they're working out the lighting here, as to whether it's in tune or not, based on forward and reflected power. And another interesting thing, you can hear that clicking. There's a micro switch underneath which changes the way the two inductors are connected up. So that's interesting. Anyway, back to the fault. So this is the socket that the antenna connects to. Now you can see in there is a pin that comes from the base of this socket that goes through onto the inductor. Now what happened in the one that I had, the nut in behind here had come loose, which had caused the socket to move a fraction, and of course the pin had broken on the inside. It was very hard to find because it's with RF, if you've got a break and the two pieces of metal are close together, it will actually act like a capacitor. So you'll still receive sometimes, but the only way I picked it up is when I noticed when I put the antenna in, I could just wiggle it a fraction and I could hear the clicking going on, so on the receiver. So that's helped me identify it. So I thought with the second unit, look, I'm going to open it up and have a look, make sure the pin's okay. And in this one, the pin is okay. Anyway, if you've got one of these and you need to get to it, I've shown you how to take the outer cover off. You need to take off this nut here, and on the other side the other nut, and once you take those two nuts off, this whole assembly will pull away, revealing a circuit board here, and these are the plugs and sockets for the two, and that will show you get you access rather to there's a screw here and a screw here, a screw here and a screw here. You can't get to those, well, you can't get to this screw unless you take this whole assembly off, and these are quite tight to get into anyway. But once you take that all off and you take those two screws off, you can then pretty much remove this board. I think there might have been, I can't recall there may have been on the, no, it all unplugged, that's right. So the board just unplugged, and that enabled me to get to the back, the nut on the back of this, tighten that up, put a bit of Loctite on it. Well, I don't use Loctite, I just use some of my nail polish. It does a good job. Loctite was the thing that they recommend, but nail polish is what I've got on hand. Let that dry, put it all back together, and the tuner worked fine for me. So there you have it. That's the manual tuner for the Grintek TR-178b. Now, an interesting thing about this transceiver, it does support ALE, which is automatic link establishment, but not unless you have an automatic tuner on it. So I'm looking at, I tried to get hold of an automatic tuner which actually bolts up here, but I can't find it. Now, the automatic tuner uses, has got a cable that runs from one of the audio connectors to the tuner, and of course the transceiver RF cable goes to the tuner, and it has its own stud on it. It has a switch to determine whether you've got dipole or using a whip antenna. But what's interesting to note is how they're controlling the tuner. There is one of the pins on the U229U is actually sending serial data, and I think it could be hooked up similar to how ICOM does their CIV, in that the one wire has both transmit and receive data. I think, look, if I remember rightly, when I looked at the circuits, it was something similar to that. So serial data goes to it, and I'm picking that is band information for the tuner. Also, this transceiver on the TR line, on the coax line, they also send 2 voltages, much like the Yaesu ATAS antenna tuning system. One of the voltages tells the tuner that it's transmitting, and another voltage tells the antenna tuner to tune. So we have 3 signals effectively going to the tuner. We've got serial data, I suspect for band, and possibly even to confirm that the tuner is attached for the main processor here, because the ALE, why I think that is the ALE options don't show up with the manual tuner. And the manual does say that ALE is only available with the automatic tuner. So I'm picking there's some sort of serial talking going on perhaps when the transceiver first starts up. Perhaps it's the first thing it does is send some serial data, but I'll be sniffing into that later, trying to work out how it all works, because I want to make an automatic tuner for it, because I'd like to be able to use ALE with these transceivers. So I can actually show you over on my computer if I can get to it. So I'm trying to move my tripod here. So here we go. It's not going to be very good. But here we see that the transmit frequency range on this transceiver is 1.5 to 30 megahertz. But what I like about it is that it actually receives down to 100 kilohertz to 30 megahertz. So it means that one of the failings I find with a lot of the military transceivers is that they only receive where they transmit. So a lot of them will only go from 2 megahertz to 30 megahertz. So you can't receive any AM band information. And my primary reason for having this transceiver is for emergency situations. So in the emergency situations, I definitely want to have the ability to receive AM radio broadcasts, because there's still quite a few AM radio stations in New Zealand, and we have a particularly hilly terrain. We have the Southern Alps down here in the South Island, and in a recent AREC meeting, they indicate that we're something like 10-15 years overdue for another major earthquake. So if you imagine we're in a rural town, and if we had a major earthquake and we're going to need communications, I want to be able to hear what's going on via the state broadcasting on the AM stations, and having a receiver that can go down to 100 kilohertz is just great. Okay, so that's that screen that I wanted to show you. The other thing I did want to talk about is to go back and have a look at this, show you the block diagram of the PA section. So I'm going to take the camera off the tripod. So this is the PA section of the transceiver, and here we see the bands, the tune. This is coming from the processor side. This is the block diagram of the RF board. So we've got our, we'll just talk about the tuning. This connecting up to here would be the rest of the transceiver or the main bus, and we have a tune signal coming on that goes to a band switch, and we also have, and this is the changeover relay. So this is effectively the 2.7 volt that they put onto the, this is the output to the antenna. So via, the voltage goes directly online via a choke to the antenna. So much the same way as, like as I said before, like how the ATAS works. And we can have a look actually on the circuit to see how they've done that. So here's the signal here for the transmit control. This is the actual transmit relay here, and then this part here, this 2.7 volt switch is the part. We can see the Zener diode here, so it's limiting it to it's a 2.7 volt Zener diode, so it's popping that on, less the voltage drop, of course, you'll get from this other diode, protection diode, I guess, that they've got here. It goes straight on to the antenna. And then we have, of course, this one here is the tune switch, battery B plus and tune switch. So when that when the tune signal comes in from here, goes to the base of the transistor, turns the transistor on, and then we've got its voltage coming onto the line as well. So the tune is looking for 2 voltages via the RF line in, plus it's also getting the RF in. So it's quite a smart system that they've used. Anyway, if you need more information on these transceivers, let me know in the notes, and I'll see what I can do. Thanks for watching my video, and cheers.